All right, so let's take a look at this last little bit. We're going to look at 3.4 different ways of expressing concentrations. So again, we're going to start with something where we're always going to have, if we have a solution, it's always going to be some part over the whole, right? Or part over the solvent. So solute over solvent, some version of that is what we're looking at. Okay, so let's take a look at the different ways that we can express it. Remember, it was moles per liter. It was what we looked at in molarity, and that's when used. That one is used all the time. That's why it has its own little section. But let's take a look at different percentages. So mass percentage. Okay, so percentage. So immediately, as soon as you see a percentage, you should see, okay, I have some part over the whole times 100. Okay, so some part over the whole times 100. If you were trying to determine the percentage of male versus female students in a classroom or on campus, you would count the number of female students divided by the total number of students times 100, and there you go, you have a percentage. So that's what we're looking at. Mass percentage is no different. It's the same exact concept of any other percentage that you're looking at. So the mass percent of whatever we're looking for, so substance A or whatever we're looking at, is equal to the mass of that solute, so solute A or mass of A, all over the total mass of the solution. So this is going to be times 100. This is going to be the combination of all of the parts. So masses of all of the solutes plus the mass of the solvent, that should be the total. Okay, so that is how we do mass percentage. Pretty straightforward. Again, A just refers to the single substance that we're interested in looking at. Good. Volume percent. Okay, so mass percentage is by mass. Okay, so and typically they would actually say this weight, and you'll see this actually on the back of like a bunch of packaging. You'll see either mass by mass or percent, or you might see something weight by weight percent. So if you ever see that, it's essentially just a mass percentage. Volume percentage, you will see volume percent, something like that. And the concept remains the same. Again, it's the part over the whole times 100. So it's going to be the volume, so the percent by volume. Maybe I'll just use the notation that everyone uses. Percent volume percent of substance A is equal to the volume of A divided by the total volume times 100. And again, volume, this will only work is if you can get a volume. So you use these percent terms depending on what you need. So must be liquid form or some version of being able to measure a volume. So if you have, so masses are measured by mass. So if you don't have a weight, you can't get it. Liquids have to be measured by volume. So again, it kind of depends on what you're doing. By the way, you can convert between the two of these. Hi, Sadie. You can convert between the two of these using a density. A density is what you would use to convert between the two, or at least the solution. So you could get the lower half of that. You could get the volume part to convert it into a mass if you know the total density of the solution. Okay. All right. Last one. This last one is used a decent amount, mass volume percentage. And that is exactly what you would imagine it is. The mass of the substance over the total volume that it's in of, substance A equals the mass of A over the volume total times 100. And again, this allows you to look at a solid in a liquid. And on the big homework assignment, we do see this looking at the amount of fluoride, hydrogen, I think it's sodium phosphate fluoride, monofluoride phosphate in toothpaste. So you actually look on the back of the packaging for toothpaste, you're going to see that percentage mass by volume. Okay, so again, same idea. You need a mass, you need a total volume. You can get a total volume from the mass with a density if you actually have the density. Okay, so those are percentages. Percentages, by the way, percent is out of 100. Okay, so percentages out of 100, that's how we look at a percentage. So then we have these idea of parts per million and parts per billion. And we really use the simplified versions of this, ppm or ppb. Those are the two terms we use for parts per million and parts per billion. So let me, we're going to look at understanding it in just a second, but let me give you the definition of these. Parts per million. Parts per million is equal to the mass of solute A. Again, this is parts per million of whatever A happens to be. Solute A over the total mass of the solution times 10 to the 6, okay, which is a million, okay, times 10 to the 6. Parts per billion is the same setup, the mass of substance A all over the mass total times 10 to the 9th times a billion, okay? So that's typically how we see these things. How you actually mostly see these things is, so 1 milligram, actually I just use a different number here. Oh yeah, I'll use 1 milligram per liter is equal to 1 part per million. Milligram per liter is another way. So if you don't know how much mass you have, but you have the volume, you can actually convert it 1 milligram per liter, or 1 microgram per liter is equal to 1 part per billion. By the way, part per trillion is a thing, just 10 to the 12th. Okay, so part per billion, part per million, that's ultimately what it means. So let's put that in context. So first of all, 0.05%, okay? Let's turn that into parts per million, okay? So first of all, 0.05% versus parts per million. So 0.05% is the same thing as saying 0.05 over 100, right? So if we're trying to figure out how to convert a percentage into a part per million, all we're simply doing is setting up a proportion. 0.05 over 100 is equal to X amount over 1 million. Solve for X, and you end up with 500 parts per million. Okay, so that's how we solve that. That's the idea. So the number that you have, if you have a mass percent or you have some kind of value of concentration, it's equal to X parts out of 1 million. That's kind of how we do that conversion. That's the concept of parts per million. And you guys, you run into it all the time, whether you know it or not. Hot sauces, the Scoville units are actually in parts per million. So a million, something that's 5 million Scoville units for a hot sauce is actually 5 parts of it are that capsaicin. So parts per million is a good way of measuring small quantities. Parts per billion is a way of measuring even smaller quantities, but we need those numbers to just make the reading easier in terms of, you know, writing things up. So next up, mole fraction. Mole fraction is an important one, and we're going to run into it quite a bit a little bit later when we took a look at some colligative properties and stuff. But mole fraction is capital chi. So let's say the mole fraction of some substance, water. We could say A, but let's just say water. The mole fraction of water is equal to the moles. I'm going to do it this way, actually. N moles of water over the total moles of all compounds in the solution. Okay, so again, the N is moles. Okay, so moles of water over the total moles present. Oh, all right. So good. All right, last little bit. The term molality. So we know what molarity is, and let me just remind everyone. Molarity is capital M moles per liter. Molality is lowercase m, and it is going to be moles of solute over kilograms of solvent. By the way, we should take this one, liters of solution. Okay, so it's very different in terms of what you actually have. So kilograms of solvent, not solution, unlike molarity, which is liters of solution. So it's a little bit different. So moles of solute over kilograms of solvent, that's equal to lowercase m. So the unit is moles per kilogram. They're not the same thing. Molality is actually preferred, but molarity is much quicker and easier to get to because it's easier to measure out the volume of a liquid as opposed to like a mass of a liquid. So changing between molarity and molality, whenever you're changing between the molarity and the molality, you always need the density. The density is what's going to allow you to shift between the two on the denominator. You can always solve for moles, they both have moles, but density is how you transition between volume and how you transition between the two. All right, so a solution is made by dissolving 39 grams of glucose in 355 mils of water. At 80 degrees Celsius, the density of the solution is 0.97 grams per milliliter. What is the mass percentage of the solute? What is the mass per volume of the sugar? What is the molality, or what is the molarity? What's the molality? Let's do parts per million, parts per billion. And commercial bleach, we're going to look at percent, mole fraction, and molality. So yeah, just solve all these based on the equations and we will go over it in class.